We are going to continue talking about proofs. However, this time we are going to work on geometric proofs. Okay, so we still have the same process where we are going to write 2-column proofs with statements and reasons. But this time we are going to get some information about a geometric figure, and we're going to have to prove something geometric about it. So it's no longer like, here's the equation, solve it with the algebra that you know. Okay. However, we still have some very similar properties that we are going to be able to use.
I didn't mean to do that.
I know, but I'm going to take it for the class period. Thank you. So we still are going to have all of these properties of equality. So we can still add, subtract, multiply, divide, the same thing to both sides. We can still distribute, substitute, reflexive, symmetric, transitive. As long as there's an equal sign, it doesn't matter if we have numbers or algebra. We could have segments. Next week, we'll look at angles, and all of our properties for equality still apply. Okay. Now, we also have some things we need to talk about in terms of congruence. So that's what we're going to add right here. Okay. Reflexive property. For equality, we wrote down like A equals A, right? Okay. Well, we're going to talk about segments and we're going to talk about congruence. So segment AB is congruent to segment AB. It's like the same thing. Okay. We also have the symmetric property for congruence. You okay? What paper? There's one in front of you, isn't there?
Why'd you walk out the hall?
It might have been in the hall. Stop laughing.
Aiden, where's the one that got wet?
And then I think it's the.
I took the one up there. Bro, what? Why you take mine?
His got wet and he threw it away. You're just gonna have to muscle through it. Everybody gets one. All right, symmetric. If AB is congruent to CD, then we know CD is congruent to AB. Am I blowing your mind, or is this pretty like, oh yeah, okay. That's confusing.
Oh, I think another line.
Yeah.
Yeah, I got it.
I watched the video.
Okay, it's the same thing, except we change the order. Okay. The last is the transitive property. If AB is congruent to CD and CD is congruent to EF, then since these two match, AB is congruent to EF. Just stop talking. Then you can ask me a question. If everyone asks their neighbor a question.
Awful.
And there's 14 people talking. Okay.
My paper is really wet.
Okay. Now, definition of congruence.
Yeah, wait, what was the last one?
Right.
Sorry, it's like the last.
Don't even think about it.
Put away the water.
Okay, now. If AB is congruent to CD, those are segments, right? If AB is congruent to CD, Jack, what do we know about the measures of the two segments? Wow, Jack has 4 voices. Okay, if the measure of segment AB is equal to the measure of CD, then we know that segment AB is congruent to segment CD. Okay, when we're talking about the measure, there is no line. When we're talking about the segment being congruent, there is a line. Okay, so listen, equality, there is no line. Congruence, there needs to be a line. Okay, and we'll talk about the difference with everything Monday with angles. Okay. Okay. Now, if I need to use, I'll go back. Okay. Definition of a midpoint. The midpoint of a segment divides the segment into 2 equal congruent parts. So if M is the midpoint of AB, then segment AM is congruent to segment MB. We know that because of the definition of a midpoint. So guess what? In your given information, if you have anything about a midpoint, one of your steps in your proof better be that right there. If you have a midpoint, you have 2 congruent pieces.
Makes sense.
Okay. Okay, the last, yes.
So what would the explanation be? Would that be the reasoning?
So like this would be your statement and this would be your reason. Definition of midpoint. Oh yeah, we'll get there. Okay. All right, now the segment addition postulate. It's something that we talked about, but like you mostly use it to solve equations. So let's write it again formally. Here I have this segment AC where B is in between A and C. Well, we can write segment AB plus segment BC equals segment AC. The 2 little ones equal the whole thing. Okay, yes.
Why is there no line?
Because we're talking about the measure. And when we're talking about the measure, we're not talking about a line. So let's talk about that since Tyler brought it up. If I, in my proof, need to use the segment addition postulate, and I know something about congruent segments, then I'm gonna have to use the definition of congruent to take my congruent statement to an equal statement. And then maybe I need to use the segment addition postulate, okay? Or maybe I have things that look like this and I need to prove something's congruent. So if I have this statement, then I can go to here because the definition of congruent. Okay, now you are not going to just like be good at this right away. How are we going to get good at this? Oh, practice. Okay, so I want you to go to the back side. Wait, what?
So there's no like division, addition, something like that.
Thank you.
Not for like this.
Because the postulate is, when we talked about the postulate in the last chapter, it's talking about the measure. Well, the segment addition postulate is measured. Yeah. Okay, I cannot hear the question because people are talking. Like Ben and Jonah and
The whole class, but you had to point.
I was going from this way to this way. What was your question, Carson?
Me?
I thought you said you had a question.
I mean, I kind of have a question. Like, do you use the addition, subtraction, division when you're like doing angles instead of measures?
Sometimes, yes. Okay, so let's look at proof number 1. So notice how we have E is the midpoint of DF. That is the given, okay? E is the midpoint, and we want to prove that 2 DEs equal DF. Okay, so first of all, if E is the midpoint, are the wheels turning for you? Like okay, okay. So we need to write step by step how to get there. Okay, so for sure, whatever is given, we put right here, and our reason is given. Okay. Now, the next thing, because E is the midpoint of DF, we know it splits it up into 2 equal pieces. So we can write that the measure of DE is equal to the measure of EF. Okay, what would be that? Tyler, what is our reason?
Definition of midpoint.
Definition.
Oh, I was.
Because E is the midpoint of DF, we can write that DE equals EF. That's the definition of a midpoint. Yes,
Would it be like simplifying those numbers? Those numbers.
we're not worrying about numbers right now. Okay. Okay, now, oh my. Look at this. Hold on. Here's DE and here's EF. Well, what did we do to both sides? We added DE. No, just addition property. I added the same thing to both sides. Okay. Now, Ben, DE plus DE equals 2DE. This is when we say simplify. Okay, now at this point, all right, I want 2DE to equal DF. Okay, well, I have the 2DE part, but I need the other side to equal DF. So look at this. DE plus EF equals DF. Where is that coming from? So let's look at the picture. DE plus EF. Okay, 2 pieces added together equal the whole segment. That is the segment addition postulate. Okay, now watch this. Are you ready? 2DE equals DE plus EF. DE plus EF equals DF.
What do you call that?
What do you call it? Yes, no. The transitive property. The transitive property is going to be huge in these segment proofs. You're going to use it quite a bit. Segment addition postulate, definition of midpoint. Those are things you're going to really have to look out for.
How to be transitive property?
What?
How to be transitive property?
Transitive property. What is your question?
How to be
So look how I highlighted. Green equals blue and blue equals purple. So we can say that green equals purple.
Oh.
Do you see what I'm saying there?
So DE plus EF.
It's literally the same.
Yeah, it makes sense.
It does make sense?
No.
Okay, then I need everybody to stop talking so I can help Cohen. So 2DE equals DE plus EF. And I know DE plus EF equals DF. So since these two are the same thing, then I can say if this equals this and this equals this, then really this equals this. Since these two are the same.
Oh. EF and DE are the same as 2DE.
Yes.
Wait, do we have to memorize? Oh, I did.
All right, here we go. Let's look at number 2. Here is our given information. So you know what else I'm going to do? I'm going to mark that KL and LN are congruent. LM and LN. What? I know, right? KL and LN. LM.
So they're all congruent. Basically, is what that's trying to say.
Right. All right. And we need to show that L is the midpoint of KM. So here's the deal. This is what I would do if I were you. Are you looking?
Yes.
Are you listening?
Yes.
I would put the given right away. Then I know that I want to prove that L is the midpoint of KM. That should be your last step. And you need to figure out how to get from 1 to the end. Okay. Now, if you are given information about congruence, then we know that the measures are equal. So I can take KL as congruent to LN, and that means KL equals LN. I can take LM as congruent to LN, and I can turn that into, hey, the segments are equal to each other. We can do that. Definition of congruence, yes. Okay.
Oh, this is easy.
Okay, Cohen, are you ready, Cohen? Okay, notice how we have KL equals LN and LM equals LN. What property tells us that KL and LM are the same?
Dude, transitive, I guess, since somebody said it.
You agree with them?
Yes.
Okay,
The tops equal each other and then the bottoms.
okay, good.
On the test, we have to put property for it to be.
If you put transitive, I'm not gonna throw a big fit.
You want us to put cost to it though?
Yes. Okay, now, if KL equals LM, if I have two segments that are the same and they share an endpoint, then we know that that is the midpoint because the definition of midpoint. Oh my goodness, now we have to do one.
Because I feel like you just make things appear.
I just make things appear, okay.
I'm confused. I don't think I was supposed to do those first.
We're gonna do it together, okay? Now, I'm not gonna just like throw you into the ocean and make you do number 3 all by yourself. Let's talk through this one. But it's really gonna be helpful if you shut your mouth so we can do that. This table, we're really struggling here to be quiet. Right. Yep. So on Friday's quiz, you're gonna have proofs that are like the algebra ones and ones like this. Okay? Yes.
On the segments, are we gonna have to find the
No, I'm always gonna tell you what we're proving, okay? All right, so here we go. Jonah,
Can you please write all the different things on the board, like all the different properties and stuff?
1,000 is accurate. I'll think about it.
At least like the basic. Actually, like all how many, what's like the exact?
I would like you to copy in your given information. PQ is congruent to TQ and UQ is congruent to QS. And we need to prove that the two long segments are congruent to each other. Okay, I want somebody to raise their hand if they have an idea of one thing they know we need to use, whether it's right now or later on in the proof. What's one thing you know we're gonna have to use? Carson.
Incorrect.
Why?
Because the Q, like, the Q's gonna put all of them.
It's all from midpoint.
No, wait, look at what we're trying to prove.
Okay, so we might have to use midpoint. Zach, what's your idea? You didn't have your hand up, Rhett? Transitive property could come up.
Definition of congruence.
Definition of congruence is definitely what we're gonna have to use. Okay, definition of congruence. Let's go ahead and just use that right away. Okay, let's write that PQ equals TQ and UQ equals QS.
That's something what we just put, right? No,
There's no.
Oh,
line,
yeah.
there's no congruence.
Okay. Now here's the deal. I am working with small pieces and eventually I want to show that the big pieces are the same. So we have small pieces and big pieces. Look at the front.
Oh my God, this.
Layla, do you have an idea? You can be wrong and it's okay.
What are we doing?
Yeah,
Stop talking like that. It's okay to be wrong. Look, what's at the very bottom of that front side?
Oh.
The segment addition postulate. The segment addition postulate tells us that PQ plus QS equals PS.
Yep.
Sure.
Right? Okay. Okay. And we know that TQ plus QU is equal to TU. Shut your mouth. Unless you want to teach this. That worked.
Wait, can you wait like 5 seconds? Just
Yes.
what exactly is that again?
The segment addition postulate.
How do you combine?
PQ plus QS equals the whole thing.
How do you combine those?
PQ plus QU equals the whole thing. PU. Ladies and gentlemen, we need to figure out how to get PS and TU equal to each other. So somebody mentioned the transitive property. If I could get these two to look the same, we could use the transitive property. So is there something we could substitute?
Substitutive property.
What?
Transitive.
Substitution property.
Yeah, okay, so this PQ is equal to TQ. Hey, look, right here, here's PQ, right? So let's take PQ equals TQ. So TQ plus QS equals PS. That's called the substitution property. Yes.
This is so hard. Oh my God. Get mixed up with my plus signs and my C's.
Facts, yo.
Okay, since PQ and TQ are the same, then I can take PQ and make it a TQ. Okay, now, since UQ and QS are the same, then I can take QU right here and replace it with, what did I say? QS. So 3 went to 5 and 4 went to 6. We have 2 different segment addition postulates we're rewriting. Okay? You giving up right now is only going to make it worse. I can see it in your eyes and I can see it in your body language. Now, I'm not talking about you. You're fine.
You're talking to me.
No. Now, TQ plus QS. I have that twice. Right?
Oh my gosh. So PS equals TQ. Wait, what's number 6's property?
Substitution. I didn't write that. You're right.
And another one.
Okay.
Yep. And then we use the transitive property. Stop talking. Oh.
Wait, we're actually, you need the line over the PS.
Oh, now since okay, I'm gonna just stop talking. Hold on.
And you also need the congruent symbol.
Just wait.
Shut up, son.
Is this what we need?
No.
No, but we know that the definition of congruence tells us that we can make those two congruent. I just made, okay, number 8. No, just write it underneath.